Hi friends, welcome back in this series of FMT. So today we have another topic, that is pipeline. I hope you have heard about pipeline, which plays a very important role in terms of model building, transforming, right, and scaling your model. So basically, what pipeline is, I'll try to start from the scratch, right? This is a very basic video regarding the pipeline, right? So almost always we need to tie together many different processes that we use to prepare data for machine learning based model, right? So basically pipeline is a paramount that the stage of transformation of data represented by these processes are standardized, right? So basically pipeline class of sklearn that helps simplify chaining of the transformation steps and the model. So pipeline along with the you can say grid search CV, mostly we use this with the grid search CV, that helps search over the hyperparameter space that is applicable to each stages. So let's discuss further regarding pipeline. So basically this is sequentially apply a list of transforms and final estimators. Then what is it is saying that intermediate step of the pipeline must be transforms, that is the must implement fit and transform method, right? The final estimator only need to implement fit. And fourth is pipeline helps standardize the model project by enforcing consistency in building, testing and productions. So basically what we do in building our model, so first we load the data, then we split the data, then we scale the data if it is required, then we call the functions like what all the algorithm we want to use, and finally we fit our data on that model. And in terms of predicting, what we do is we first load the data, then we split the data, again we scale the data, we call function, and finally we predict it. So there is a difference between model building model and predicting. That is the last step, where in model building of course we will do the fit, and in model prediction we will do the predict. Now if we move forward, so basically we have the steps that how we can build a pipeline. So first we import the pipeline class. In our case, of course, this is sklearn.pipeline. We import pipeline, then we instantiate the class into an object by listing out the transformation steps in the following example. Scaling function is followed by the svc algorithm. So this could be the calling, I mean the pipe equals to, we can store all these. Then we call the fit function on the pipeline object. That means we simply do the pipe dot fit, right? And finally we call the score function on the pipeline object, or to predict a function. So we do either pipe dot score or pipe dot predict. So here you can see in this step, the pipeline object is created using a dictionary of key value pairs, right? And the key is specified in the string. For example, we use scalar followed by the function to be called, right? So here the key is the name given to a step. Now if we move forward, so this is nothing but this is the again make pipeline, how that works. So first we will do, so here what we will do, so we have a different so here these are the basic steps that I have just described in detail, right? So in using these steps we can achieve our pipelines, right? So we download the data, we create data frame, we split x into y, then we transform y into numerical using label coder, right? Then we split data into training, testing, then we standardize data using standard scalar, use PCA, principal component analysis, to reduce to 2 dimensions, right? We use logistic regression on the reduced dimensions, and finally we create a pipeline, and then we do a fit and score. Okay, now before wasting our time, let's start with a case study. So we are importing all the necessary libraries, of course, from the sklearn. Then we load the data. So basically we are using load breed cancer from the sklearn.data set, right? So it will load the data. Now we are getting x train x test, y train y test. From this train test split, we are using data as cancer.data, then we are using cancer dot target, right? Random state we are passing 0. So here commute minimum and maximum on the training data. Now we are scaling it, so we are applying min max scalar dot fit on x train, which is storing in our scalar function. Then what we are doing is we are doing x train scale, so scalar dot transform of x train, right? Then we are applying svm. Okay, so SVM variable will store the SVC that will learn an SVM on the scale training data SVM dot fit, right? This way. Then of course we will do the fit on X train scaled and Y train. X test scaled equals to scalar dot transform X test. Now we printing the test score. So here it is. Now test score dot format. So SVM dot score X test scaled Y test, right? So here we are getting the test score as 95% on that data, right? Now we are using the pipeline to link all the steps into one single object, right? So here we are importing the pipeline. Then what we are doing is pipe equals to as I described in these steps, so we similarly do here. So these were the steps for your reference, guys. So pipe equals to pipeline, we are storing that scalar here, min max scalar as well, and the SVC, right? Now we are doing pipe dot fit on x train y train. So here you can see that it will return us some detailed, like the memory, steps, decision function shape, kernel, right? All these stuff. Then printing, then we are printing test score again. In our case we got it as 0.95. Similarly we got here as 95%, right? Now y prediction equal to pipe dot predict x test, right? The prediction will be stored in the y predict, or we can say the pipeline prediction will be stored into y predict. Now from sklearn import matrices to import the classification report. So here we get the precision, recall, F1 score and support, all these. So here you can see all these parameter, and we can if we talk about 0 1, right? So precision we are getting 100% for 0 and 93% for 1. Similarly this is for recall, F1 score, and if you check any other micro average and weighted average, you will get it like here. Now we make pipeline for simpler pipe, right? So we import the make pipeline from sklearn. Now pipe equals to make pipeline min max scalar, passing the SVC as second parameter, and we are printing the pipeline steps, right, in format of pipe dot steps. So here you can see pipeline steps. First we get the min max scalar copy is true, so all these values you will get. Then decision function shape again, right, and gamma value, degree, kernel, all these stuff like that. Now we have pipe dot fit, so we are doing the fit on x train y train, so it will fit our model, right, in the pipe dot fit function. And finally we will get the test score. So again we are getting it as 95%. But it was the basic video about the pipeline, but you guys can research more on it, and you can do more hands-on on it, because beyond that we do several things. For example, we always do the hyperparameter and tuning, right? Let's say and hyperparameter and tuning, and then we can do grid search, or we can design grid search with the pipeline, of course. So like if I talk about grid search with the pipeline, so we basically use the data set again, then we standardize the data set using again those standard scalar, then we use first PCA and we use SVC, right? Then we create a pipeline for scaling PCA and SVC. Okay, then we create a parameter grid for PCA as well as for SVC stage separately, right? Then finally we will use grid search CV, say with 5 CB, right, for example. Then we print the best parameter, and finally we can get the best score. So this way you can again use randomized search CB as well, So all these thing we can apply with the pipeline. So hope you get the basic idea about the pipeline. Hope you enjoyed it. If yes, please do like, share and subscribe. We'll we get back to you very soon with another content, right? So till then, all the best. Thanks for being with us. Have a good time.